Now in the previous lecture, we have learned BFS method for single source shortest path problem. And we have learned that if a graph is weighted, we cannot solve single source shortest path problem using breadth first search algorithm. So breadth first search algorithm can be used if our graph is unweighted. So if the graph is weighted, in this case, to solve single source shortest path problem, we need Dijkstra's algorithm. So let's see how the Dijkstra's algorithm solve single source shortest path problem in case a graph is weighted. So here we have a graph like this, and you can easily see that this graph is weighted because in this case from the nodes over here we have a cost for each edge over here. So this means that if we have costs for each edge, this graph is weighted. So we are going to find single source shortest path problem for this graph over here using Dijkstra's algorithm. Now the first step over here is we are setting initial cost value. So in this case, if we are starting from A will be the starting point and the initial cost of A will start from 0. And all other nodes cost will be set to infinity in this case. So after doing so, our graph will look like. So in this case, you can easily see that in A the cost is 0. For other nodes over here, the cost is infinity. Then starting from the present node, which is in our case A, we are going to search for unexplored points. So once we found, these points become the candidates for the next move. So in this case, from A, unexplored points are B and C, because in this case from A we can go on to B and we can go on to C over here. So as the starting point is A, so unexplored points in this case B and C. Now then we are going to calculate the cost of B and C based on the edge over here. So the equation for calculating this cost is like this. We are taking the initial cost of starting point and we are adding the edge cost and we are getting the cost of the point that we are going to. So in this case, after calculating it, 0 plus 2 will be the 2, so this is going to be the cost of B, and 0 plus 5 will be 5, so this will be the cost of C over here. Now after finding the cost of unexplored points, in this case we can find out our move. So we need to move either to the B or C. So it's obvious that we are looking for shortest path, so this means that we are going to continue to the path in which the cost is minimum. So the cost of C is 5 and the cost of B is 2. So this means that we are going to continue to B. We are moving to B. Then we are going to continue again the same operation over here, same steps over here. So here again we are going to look for unexplored points. So in this case, from B we can go to C, we can go to D, and we can go to E. Then based on this edge over here, we are going to calculate the cost of these points over here. Now if we calculate the cost of C, we can see that 2 plus 6 is 8, but the cost of C is already calculated. So if the calculated cost is less than the cost that we are calculating here, we are not updating the cost of that node over here. Then we are going to continue to the next node. The next node is D. So the cost of D in this case, 2 plus 1 will be 3. And the cost of E will be 2 plus 3, which is the edge cost. So in this case, it's going to be 5. Now after calculating the cost of unexplored points over here, we are going to search for the minimum one. So in this case, we can easily see that in E we have 5, in D we have 3, and in C we have 5. So this means that the minimum will be D over here. So we are going to move to D over here. Now after moving D, we are going to find unexplored point for D also. So in this case, from D we can go to E. So if we calculate the cost from D to E, we can see that 3 plus 4 is 7, but we have already calculated the cost of E. So this means that 5 is less than 7. We are not going to update it. So here again, we are going to search for the minimum node. Now in this case, if we go from D, the cost becomes 7. So that's why we are going to continue the cost of C over here. Because in this case, the cost of C is 5. So we are going to take this one, which is the minimum. Then from 5, we are going to continue to the next node. Next unexplored point. So in this case, from 5, we can go to the F. So the cost of F in this case will be 13 because 5 plus 8 will be 13. So we have calculated the cost of F. Now after calculating, we are going to compare one more time these nodes over here. So we are going to compare E with F. So we see that in E we have 5. So this means that we are going to continue from E over here because E in this case is with the minimum cost. Now from E we can go to the G. So if we calculate the cost from E to G, the cost will become 14. Now in this case, one more time we are going to compare G's cost with the F's cost, but in this case you see that F's cost is less, so this means that we are going to continue from F over here. So because in this case F's cost is minimum. Now after reaching the F, so from F we see that we can only go to the G, so we are going to calculate the G's cost based on F. So if we calculate it, we see that it becomes 20 because 13 plus 7 is 20. So this means that we are not going to update the G's cost. So this means that the shortest path to G will come from E over here. So this means that the shortest path to G will come from E over here. Now if you look for the minimum path from A to G, the path will look like this. Now with this solution we have calculated the shortest path to other nodes as well. So this means that to go from A to D we have to go A, B, D. To go from A to C we have to go directly C because the cost is 5 over here. And to go for example, from A to F we have to go A, C, F. So with this graph we have calculated the minimum cost from A to all other nodes in case of weighted graph. So with this we have come to the end of this lecture. So in this lecture we have learned how Dijkstra's algorithm works in case of weighted graph for single source shortest path problem. So hopefully everything is clear about the logic behind the Dijkstra's algorithm. So see you in the next lecture.